So let's work a multi-group confirmatory factor analysis. So I am re-recording this assignment from last summer because the code for this has updated since the last time I used it. Additionally, you can watch the previous video on how you can do these measurement invariants with more control. And I probably explained just a little bit more than I'm going to do in this video. I'm going to kind of do a quick work through of this particular class assignment, but there are other examples if you're interested in learning more about multi-group models. So we're going to use our resiliency data set we used in the lecture, and then the example, and then this time test ethnicity, race, instead of men versus women. So I'm going to look at the differences in black and white individuals. And obviously the first thing we're going to have to do is make sure our variable is factored. So let me import my data set. I'm going to start by creating a working directory. I'm going to set that to where I'm currently working. Oh, well, it would help if I save the data set first, right? Let's save our script here to assignments. Right, this is 11, multi-group confirmatory factor analysis worked. Now I can set it to where this file is hidden. You can also click this button right here. It'll show you what files are in your folder, which is really helpful because now we're going to import that file. So I'm going to call this master and use the read.csv function to import. I don't know what I'm hitting here. Shift. Oh, I'm hitting enter instead of shift. So it's 11 multi-group confirmatory factor analysis CSV. So what this data set has in it is a couple of different variables, but we're really interested in this race test variable because what I've done is taken ethnicity and collapse it into, or just cut out and do black and white. And then we're going to test this 14-item resiliency scale. So let's factor that variable first. And it says black is number 1. Okay, so we're going to just rewrite the variable. Oops, wrong button. Oh, gracious. Let's try again. Factor, the factor function, the first thing you do is the name of the variable. So I need to stick this variable in my data set. What levels are there currently? Well, the levels are 1 and 0. I could do 0 and 1, or I'm sorry, 1 and 2, 1 and 2. Sorry. 1 and 2, 2. And then now I'm just going to add labels. So the first one is black, the second one is white. And what that did, if I look at it, I have no idea why that actually ran. That's really odd. It shouldn't have. But if I look at the variable, I have 106 and 358. Now for a multi-group model, that's not necessarily ideal. I would prefer to have more in my black group, but it should work okay. Now, let's just skip straight to testing these variables. So first thing I'm going to have to do is build an entire model, so an overall model of the resiliency scale. So let's just call this overall model. And this is actually something we worked in the class assignment, but just rewrite it here. So resiliency is approximately equal to RS1 plus RS2, etc. So there are 14 questions. Add them all up here. So here's our model. Now we're going to run that overall model. So I've built it. Now I can't spell. Oh my gosh. Okay, so overall model.fit. We're going to use our CFA function. The first thing that you put in is the model name, so overall model. Data equals, in this case we called it master. Remember, you need to turn on mean structure equals true. So I have that example open here, so just to kind of show you, what we're doing is this piece right here. Could not find function CFA. Oh, well, that is kind of hard if you don't open the library. So let's open SimPath. SimPaths. It's been a long week. Sim plot, sim path is the function. Good gracious. There we go. We're also going to, I'm having a little bit of interference here because we're also going to use sim tools. There we go. Now we should have everything open we need. So let's try running this again. It gives me a little warning that I didn't tell it model equals overall model, but that's okay. So now let's look at a summary of that model. I don't have any negative variances. I didn't turn on R squared. Let's turn on standardize equals true 2 to see some of this. The other one I'm going to turn on is fit measures, but I'm going to leave that one off for a second. Okay. So all my R squareds are less than 1, my variances are positive. These variables appear to load very nicely on their scale. And so for that overall model, what we're going to do is include chi-squared, degrees of freedom, SRMR, and CFI. So I should, and I don't actually seem to get those from the summary function, mostly because I turned on mean structure. So what I'm going to do is do fit measures. Okay. Oh, I don't get them from the summary function because I forgot to ask, not because of mean structure. My fault. So here, I should do fit dot measures equals true. There we go. Now I see them. I could also just use the fit measures function. So with chi-square, I'm going to make sure I use the right one. So I got 77 degrees of freedom here. My RIMC is 0.087. SRMR is 0.041. Okay. My CFI is 925. CFI is really important because that's the one we're going to use to compare models. Now let's try that exact same thing, but with only white individuals. So I'm going to subset out my groups into different data sets. Not group, race test equal white. Okay. So if you're having trouble with subsetting, I have some data screening videos about a subsetting, so I would tell you to watch those. But be sure you use equal or you're going to get everybody. Okay. So I have white and I have black now, and those numbers match what happened in my table earlier, so that looks good to me. I'm going to copy these two lines, or two sets of blocks of code rather, and I'm going to create a white group, a white set and a black set by changing the name of the data set. And that's all that really matters. So I could do overall fit.w, so I get a different one. But I don't want to overwrite my original file. But really the only difference here that we've changed is which data set we're looking at. Okay. Right, so positive, not over 1. These look like they're fitting pretty well. Let's look at our fit statistics. Okay. I thought for a second there it was exactly the same. I was about to have a moment that I had done something wrong, but it's just the numbers are very similar. Okay, so you'll still have 77 degrees of freedom until we switch to configural invariance. Our RIMC 0.098, 0.047. Okay, and that was 90 something. I saw it. 2. Okay. So slight decrease in fit, but not significantly. Let's look at our black group now. Okay. All less than 1. All positive. Great. These look like they're loading pretty well. And then our black group actually fits very well, which might have to do with the small sample size. It's harder, sometimes a little harder to trust small samples because the rule of large numbers. But it fits pretty well, so I'm not concerned that there is a large difference between the configurations. So at the moment, I can't tell if these sort of differences here are significant. And so we're going to nest them together and force them to be the same and make sure it still looks okay. But I'd say given these numbers, they're both good enough to move forward. And certainly they're both in the publishable range. So let's look at configural invariance and run just, everything at once. So that's the nice thing about this new SimTools package component, is that we can do all of the measurement invariants kind of quickly. This is a little new to me, so I'm going to copy my code from my example here. So I'll turn off scientific notation, just so that I can read my CFIs better. I'm still going to use my overall model. Data now is back to my master data set. My grouping variable is race test, and we want to leave strict on. It's unhappy with me because it contains missing values. So if you want to, you could do master equals na.omit master. So we could exclude out everybody who's missing any data point. Clearly, we would normally have data screened this particular thing. Or we could just subset out so we don't have any missing data. So I don't know why I typed the word subset again. Let me try that. Race test underscore, goodness, equal black, or race test equal white. Okay, let me make sure I did that right. Yeah, so that eliminated the people that have missing data. So I can do master no missing. I don't think it really affects anything too much. So here are the numbers that we should get. But just in case it does, let's try that. Okay, nah, didn't seem to affect anything. So I'm gonna copy this. And let's work here down. So for that configural invariance, I don't get chi-square or any of that. So I'm going to pull those out separately. So this is, I do get them slightly above, but I didn't copy that at the moment. So 912, 912. So we're doing good, doing good. Intercept 0.901. So the change here is 0.000, 0.011. Oh boy, that's no good. So I'm going to stop right there because the purpose is to figure out if we can get to partial invariance. So I've already missed it here. So the answer here is no, and the answer here is yes. So we're going to play with partial invariance on the scalar step. Okay. So I'm going to here add some partial invariance steps. Now I do still want those other statistics. And you really want to copy them before you start changing stuff, because they will change once you start letting items be free. So you want to make sure you're copying the statistics back. In the step that you're running it and not at the very end. Okay, so for metric invariance. And this number. And then I'm going to ignore the last one because I haven't technically gotten to these two yet, right? I have had to stop here. Now, if I wanted to pull my RIMC and my SRMR, this is where we're going to have to save those data steps. So what I could do is do something like fit measures. This isn't quite how I did it in the lecture notes, but you'll see. So let's pull fit configural. Okay. So what I did in the lecture notes was I saved it and then I opened it, but not totally necessary. So let's look at our RIMC here. So our RIMC is 0.094. Oops, where's that pasting? There we go. SRMR is 0.047. So that didn't really change just a whole lot from especially the original model. So configural invariance is met. Our two groups have the same configuration. Now if I look at what's next, loadings, that is also met because there's not a significant drop in fit when I add in the loadings over configural invariance, which is good. Now scalar invariance clearly is not met. Let's type this up here. Save it. So something goes awry at the intercepts level. Did I copy the right one? Nope, I put that in the wrong place. I'll fix that in a second. All right. So scalar invariance at this step has not been met. Okay. So what I would need to do now is to run some partial invariance. So this is kind of the question here. What CFI am I trying to get to? Well, actually, I only need 0.001 of a point here. So I'm trying to get to 0.91. Sorry, 0.91 minus 1, so it's 912 minus 0.01 is 0.902. Okay. And I was very close. Okay. So what questions should I freely estimate to reach that partial invariance? Well, let's try that. Okay. So we're going to run this partial step, and now our type in the lecture was strict, but in this particular case, we stopped at the intercepts. Okay. So remember, metric is loadings, scalar is intercepts, strict is residuals. So I think you do intercepts. Let's see if it's intercepts or intercept singular. It's running, so looks like I did it right. And what we're also going to do is save those results. So we're on intercept free equals partial invariance. Oh, wait, sorry, partial, what I saved it as, results. Okay. So my intercepts, I'm going to click on them over here, click on CFI, pick the biggest one first. So the biggest intercept problem is RS4. So you see this code looks a little different than my example because that was over residuals and this is intercepts. So I'm going to copy this over here, come back, I'll stick it there for a second. Now what I do is I take my multi-steps that I did before, and we're on step 2, so to speak. Now we're going to do group.partial. So let some things be free, and I'm going to cut and paste this RS4. Okay. Let that run. So I'm going to make a note here. So I did RS4. And so that's the question here. And let's see if that solved my problem. So I am here. Now my intercept fix is 0.907. And so the change is 0.09. Am I copying that correctly? This copied better a minute ago. Oh, change CFI delta. Oh, that's RIMC. I'm sorry, I'm looking at the wrong thing. Okay, so it's 0.907, so my change is 0.005. So I am good. Okay, so 0.907, change is 0.005. So I am excellent. Happy faces. Okay. What I want to do now is pull out my fit measures so I can finish my table here. I'm really just interested in that intercept step because the rest of the steps should not have changed. And you notice these might get just a little better because we're allowing things to freely vary at this point. My chi-square degrees of freedom should only be one different, so 179. So that was met. I could continue and go on to strict invariance after meeting that partial invariance. So if I look at the residuals, the CFI is 0.886, and that is a change of 0.015. Wait, I'm sorry, look at the right one here, 0.893. That's a change of 0.014, and so that is also a significant difference. And before I go any further, I'm going to look up the fit measures for that one. Okay. So this is the fit before I change anything. The model doesn't look too bad. So maybe there's just one question that is not invariant. Let's see what happens. So if I try now, what am I trying to get to? I'm trying to get to 0.897. So let's see if we can do that. We're going to do this partial thing again. This time we're going to switch to strict and change this to the second step. So don't undo what you just did. So I'm doing partial invariance for my multi-steps on the strict level now. And we're going to talk about the strict free variables. Okay, now it takes a second to run. Give me a couple warnings. Okay, so strict free. Now let's look at CFI. So it looks like RS3 is the problem. So let's let RS3 be free and see if that solves our issue. So we're on multi-steps 3 now. Okay. Still using all the same variables, but we're going to add in another group partial. So remember, add as you go, don't replace. And then our fit measures for that one let me clarify here. This is an intercept. Stick my fit measures in here. My fit measures for that one indicate that's 0.897, so I squeaked by because it has to be a change in fit greater than 0.001. I'm sorry, 0.01. And so I would say no. Yay. Oh my gosh. Consistency. There we go. So I want to pull out my fit statistics for that one, so I'm going to do fit measures, multi-steps 3. Of residuals at this point. And it probably hasn't changed too much, except for chi-square and CFI, because those are the ones that are going to change the most with constraints. Because all we've really done is change 1 degree of freedom. So this is the sort of table that you would need to turn in. That includes all the different steps, and that's how I'd pull them in sort of a quick way. So are the groups invariant? Yes, partially. Okay. So where did it break down? Well, we have one question at the strict, intercepts level, so scalar level, one question at the residual level, so strict level. Okay. What does that imply? I don't know. Let's figure that out. So let's pull for black and white participants at the scalar level. So we've got RS4 here. Let's pull out their loadings. Okay. So I can do this on the last model. So we'll do parameter estimates of multi-steps 3, because I have to do it in a model where those loadings are free to vary. And let's pull out fit. We can do the last one if you'd like, residuals. And this will give us both of them. A little hard to read, because then I'd have to remember who group 1 and group 2 are. So I could also just do summary of our last one. And that one's a little easier to read because I don't need those confidence intervals. So let me see here. I'm looking for RS4. So remember, this is open here because there's 2 different groups. So black is first here. And their estimate is 5.13 rather. So that is our average score on that question. Now clearly whites are going to be different, so I'll come down here to white intercepts 4.24. So on this particular question, which I know I don't think I gave you guys a scale, but let's look at the RS14 here. So number 4, 1, 2, 3, 4. I am friends with myself. Black participants are picking a much higher, a significantly higher number than white participants. At the strict level, the problem was RS3. So for black participants, let's go back over here. This is going to be variances. So let me scroll up here. RS3 here is 3.31 rather. And then for white participants, it's that's the intercept, 1.80. So the variance is much higher on the black participants for RS3 than white participants, like almost double. So number 3 is I usually take things in stride. So while they have the same mean, black participants are using the entire scale, white participants are using only close to the middle of that scale. Otherwise, the scale is invariant, meaning people answer the same, the structure is the same, the intercepts are the same, and the variances are the same. So in general, I would say these 2 questions just are slight differences between ethnicities. Otherwise, the scale is mostly invariant.